Hello again. In the previous lesson, we studied increasing, decreasing, constant behavior, things like extrema, and the average rate of change. In this lesson, we're going to classify functions as either even, odd, or neither. Okay, even, odd, or neither. And we're going to use algebra, a graph, and a table to do that. So let's begin with a quick review, quick lessons that you'll quick rules for this lesson. Okay, so first of all, even functions mean that when you substitute negative x into the function, it generates the function and the function is positive. That means it's symmetrical with respect to the y-axis. Odd functions mean when you substitute a negative x, the entire function becomes negative and the symmetry is symmetric with respect to the origin. You have to be careful here because sometimes you have to factor out a negative, okay? Um, Neither is when you substitute the negative x into the function, then it is neither this outcome nor is it this outcome. So if it's neither of these, then the outcome is going to be neither. And then for tables, even means the same outputs. Odd means opposite outputs. Okay, so we'll look at all of those things. So the main idea is simple. To test a function, we replace every x with a negative x and to simplify. Okay, so let's begin. First of all, let's use algebra to classify each function. And we want to show f of negative x and simplify completely. So here we have three problems. A, f of x equals x fourth minus 3x squared plus 2. G of x equals x cubed minus 5x. And then C is h of x equals x squared plus x. Okay, so let's deal with part A first of all. So again, we're substituting. It says show negative x into the function. So I'm going to use A first. So I'm not going to rewrite the problem because I don't want to run out of area over here. So just know I'm using this expression. So I'm saying substituting negative x into the expression. That's going to be negative x to the fourth minus 3 negative x squared plus 2. Okay, notice all I did was substitute the negative x into the equation. So even powers remove the negative sign. Anytime you have an even power like 4 or 2, then the negative sign goes away. Okay, so after doing that, we're going to compute it. So this is going to give me x to the fourth. And then again, this is going to be a positive, right? Positive x squared, which is multiplied by a negative 3. So it's going to give me minus 3x squared plus 2. So f at negative x is going to give me this. Now notice what the original equation was. The original equation was x to the fourth minus 3x squared plus 2. So notice how after computing the negative, the the result was the same as the original. Okay, so if this happens, if it's the same, then this means that it's even, and it means that its symmetry is about the y-axis. Okay, its symmetry is about the y-axis. Now let's look at B. Okay, so B is g of x equals x cubed minus 5x. Okay, so I'm going to go ahead and substitute the negative in there. Negative x cubed minus 5 negative x. Okay, and when you have an odd root, an odd cube or an odd power, it's gonna generate a negative outcome. And then here we have a negative 5 times a negative x, which is going to give us a positive 5x. And now notice this is a negative, so we have to factor out a negative 1 in this problem. So extracting the negative, we'll end up with x cubed, and this will be minus 5x. And then so notice with factoring, if I factor out the negative, then I can put this in parentheses. I can say x squared because if I return the favor, if I distributed the negative back here, negative 1 times this would give me this, and then negative times a negative 5x would give me that. So this is just factoring, okay? So when I factor this out, notice the difference. Okay. After factoring out -1, we end up with negative parentheses x cubed minus 5x. So essentially, g of -x equals negative g of x, right? Because this is g of x, okay? So what does that mean? That means that this is an odd function, okay? It's odd and it's symmetric at the origin. And then part C, okay? We have h of -x, which is going to give me -x squared plus -x. Computing this, remember when you have an even power, this is going to give me a positive x squared, and then this is just going to be minus x. Okay, so h of -x. So notice this. This is not the same as the original. The original was x squared plus x. So this is a little off. So after comparing this, we notice that um, that the h of x equals x squared plus x was the original. So if we were to say that this is not equal to h of x, which is essentially what we say when we look at these two, so the function is not even, right? Now let's compare h of -x to if this was a negative, right? Suppose if we took the negative version of this, okay? So if we said uh we said h negative h of x, and then we substituted the negative into the original expression, which is x squared plus x, what would be the outcome? Well, we would have negative x squared minus x. Okay, so notice this one doesn't match either. So h of -x is also not equal to negative h of x either. So what can we say? That this one is a neither. Okay, so we just had to run a couple tests. After running the first test to see if the negative works, if that doesn't work, then try making the entire function negative. If that one doesn't work, then you know that that is a neither function. Okay, let's look at example number 2. State whether the graph is even, odd, or neither, and identify the symmetry. Now when we look at this graph, we got to understand that this graph is a parabola shaped graph. Okay, so the left side and the right side match across the y-axis. Okay, so that means that the graph has y-axis symmetry. In other words, for every point on the right side over here, there is a matching point on the left side over there. So essentially, the point pattern is this: if we have an ordered pair of x, y, that tends to negative x, y. Okay, and so that is the graph pattern for an even function. Okay, so for an even function, this is how it would look. Now, suppose if I said f of -x and I said it's equal to f of x, well, the answer would be even. And then we would say symmetry about the y-axis. Okay, so this graph is not odd because it does not rotate onto itself around the origin. In other words, like suppose if I wrote like if I did a graph that looks like this, and I took off this piece and I rotated it, it would be this. It would look exactly like this, okay? So in this case, this one does not. So this one is symmetric about the y-axis, okay, as you can see. Let's continue. Pause and try this problem. Okay, so determine whether px equals x to the fifth minus 2x cubed plus 6x is even, odd, or neither. Then state the graph symmetry. Okay. So first of all, we have to replace every x with negative x and then compare the result with px and negative px. All right. So let's first of all replace uh, x with negative x. So we have p negative x. We have negative x to the fifth minus 2 negative x cubed plus 6 negative x. Computing this, we have odd here, so this is going to be negative x to the fifth. Negative times, or excuse me, this is going to be a negative, right? So a negative x cubed. Negative x cubed times a negative 2 is going to give us a positive 2x cubed. And then this is going to be a negative 6x. Okay. Now, from here, we need to essentially extrapolate the negative here or factor it out. So p negative x, so this will be negative x to the fifth minus 2x cubed plus 6x. Okay, so p of negative x is going to be equal to negative p of x, right? Okay, negative px is equal to, or excuse me, where p of negative x is equal to negative p of x, okay? So this matches the odd function test, okay? So the answer would be odd and origin symmetry. Now, a polynomial with only odd powers of x and no constant term is essentially often called an odd function, but the safest method is always to test this, okay? You need to always test that. Now, let's look at example 3, complete the table. So we have the function f is even and the function g is odd. Complete all missing values without using a formula. So we have the inputs are -4, -2, 0, 2, and 4. And then again, keep in mind, when you have a function at x, we're saying that when you put in a -4, out comes a 7. You put in a -2, out comes a -3. You put in a 0, out comes a 2. Same thing for the g of x. You put in a -4, out comes a 5. So the function f is even, okay? So we're told that this is even, okay? We're told that this one is odd, okay? Just to keep that in mind, okay? Because that's very important. So for an even function, the opposite inputs have the same output, okay? Opposite inputs have the same output. So since f at -4 is equal to 7, that means f of 4 is also equal to 7, and vice versa. So this is -2, this is +2, so this is going to be a -3. Okay, so f of -2 is going to give us a -3. F of 4 is going to give us a 7. Okay, now the value 0, f of 0 is already given, so that's very important. F at 0 is going to be 2. The final is 7, -3, 2, -3, 7. Now, this is an odd function. G of x is an odd function. So an odd function is essentially saying that opposite inputs have opposite outputs. Opposite inputs have opposite outputs. So um, since g of -4 is equal to 5, that means g of 4 is equal to a negative 5. Since since g since g of negative 2 is equal to negative 8, g of 2 is going to be equal to positive 8. It's that simple. And then, of course, g of 0 is already given. Okay, so just to complete the row, we have 5, negative 8, 0, 8, negative 5. So the table rule is even functions repeat the same output, and odd functions change the sign of output. Okay, very important. Let's look at a common mistake. So balance does not always mean even. A student says any graph that looks balanced is even. All right, correct the statement. So the statement is not precise because, again, things can look off to the eye until they're tested, right? So a graph may look balanced, but that does not automatically mean that it's even. To be even, the graph must have y-axis symmetry. So the even test is very simple. The even test is f of negative x must generate a positive function. That's the even test. And so the point pattern is the ordered pair, and it tends to a negative x, y. To be odd, the graph must have origin symmetry. So the odd test is replacing x with a negative x, and then the function itself becomes negative f of x, and the point pattern is x comma y tending to negative x comma negative y, and that's essentially the origin symmetry and y-axis. Okay, so y-axis symmetry and the origin symmetry. Okay, and then if neither of those pass the test, then you know that the answer is neither. Okay, so let's review the main ideas. Again, the main ideas are simple. Um, Always replace the function with negative x to determine whether or not it is symmetrical about the y-axis or symmetrical about the origin. If it's symmetrical about the y-axis, then it's going to be an even function. If it's symmetrical about the origin, then it's going to be an odd function, and it's going to be a negative function. And in some cases, in order to determine its validity, you have to extract the negative one by factoring. And then if the function does not fit either test, then it's going to be a neither function. And when you're completing a table like we did on the back, even means the same outputs, odd means opposite outputs. Okay. And again, thank you for watching.